Hello and welcome to this TTA TV video. In today's video, we'll be exploring conic sections. If you cut or slice a cone at a particular angle, you get different shapes. These include the circle, the ellipse, the parabola, and hyperbola. In today's video, we'll be focusing on the parabola. The parabola is a unique shape because it occurs naturally in many experiences that we would see every day. We'll be exploring these further later on in the video. The first thing we're going to do is look at product design and why the uniqueness of a parabola helps product designers to enhance certain products. If we take, for example, satellite dishes and torches, parabolas play a huge role in the functionality of these. Starting off with a satellite dish. The function of a satellite dish is to accept incoming signal. The surface of a satellite dish is designed so that it is parabolic. What this means is that incoming signals will bounce off the satellite surface and reflect to a central point, a receiver. The same concept works with a torch, except in reverse. So if we take the central point and we reflect light onto the parabolic surface inside a torch, this will then reflect outwards, emitting light. The reason this works is down to a property of a parabola, which means that its focus point defines it. If we take a point on a plane and call it a focus, and then some distance away from that we draw a line and call it a directrix, we now have the constraints of a parabola set up. The curve for a parabola is made up of a series of points which are equidistant from the parabola's focus point and its directrix. What this means is, in order to draw a parabola, we have to find a series of points that are the same distance from the focus point and the directrix on screen. The simplest point to find would be the midpoint between these two. In order to do this, we draw a perpendicular line from the directrix which passes through the parabola's focus. The halfway point between these would be equidistant. This point is known as the vertex of a parabola. Now, it wouldn't be possible to draw a parabola with just one point because it would simply be guesswork. So in order to enhance our accuracy, we find more points which follow that rule, that they are equidistant from the directrix and the parabola's focus point. So to do this, we can just take a set distance, I'm just going to call it x for now, measure that distance from the directrix, and draw a line which is parallel to the directrix. Now if we take distance x and mark it on our compass, and strike an arc from the focus point until it crosses over the line we've just drawn, we will find a point which is equidistant from the focus and the directrix and satisfies the properties of a parabola. Therefore, it's a point on the curve. If we repeat this process several times, we will find more points and hence increase the accuracy of our curve when we're drawing it. The relationship between the parabola's focus point and its directrix defines what shape the parabola is. For instance, if we take this example here, which is a certain distance from each other, we get this curve. If we were to narrow that distance and bring them closer together, we will get a different type of a parabolic curve. And likewise, if we were to change the orientation of the directrix, the parabola will follow suit. Like I said earlier on, parabolas are evident in our environment. They can be used in man-made structures, but they also occur naturally. The first sample here is a bridge in the UK, which was opened in 2001 and is unique in terms of the shape of it being parabolic. The pedestrian and cyclist bridge tilts up to allow boats to travel underneath and then returns back to being a pedestrian walkway when it goes back to ground. This bridge is often known as the winking eye bridge due to its unique shape. Here we see a 2014 NBA playoff between Houston and Portland, where a last-minute shot wins the game. When we examine the shot further, we can see that when the ball leaves the shooter's hands, it forms a perfect parabolic path into the net. This happens in many sports and would be an interesting thing to explore as a group. So that's it for today's introduction to the parabola. In further videos, we'll explore how to construct one using your drawing equipment, and we will also look at other types of conic sections. We would encourage you to subscribe to the TTA TV channel to get more videos like this.